I'm going to start by passing around a box of 3D printed griffins. Canisius College mascot is the golden griffin. If you haven't encountered 3D printed goods, you probably have, but you may not know it. And so this is just give you can take one of these if you want. If you're not interested anyway, you get a sense of. These were printed using the same technology that's printing away right here in this corner, which is called FDM. Tyler will speak a little bit about that. But in any event, I'll start these around. We got a few minutes.
I guess you're getting your first review. The joy that it is.
And what we're printing is not very exciting looking. It's because we don't, when we do this demonstration, we don't generally come in with the idea of what we're going to print as a demo. Well, when we were walking in, we saw that the doorstop of this room really needs replaced. Well, we have our 3D printer here. We have a doorstop design we did for our rooms in Old Main. So we just said to the printer, hey, fire out a doorstop, and we'll leave it on the way out for whoever has to teach in here Monday morning or this afternoon's events. And that's sort of a reflection of, you can print all sorts of really exciting things with 3D printing. Sometimes the least exciting things are the ones you need now. And you know, the supply chain for a university is probably like for other big institutions. So that's like, you know what, you figure 3 weeks and a purchase order and approvals and
so I probably should have restarted my computer so that, I only had Google Chrome open, but I wasn't paying attention. Anyway, so what we're going to go through really quick is I created a kind of like a website for this. And if anyone is interested in the website, you can actually use this QR code to go to the website. My name is Tyler Krompiatek. I should have started off with that first. I am the instructional designer here at Canisius College, which is soon to be called Canisius University, which is kind of exciting. Should I stay up here? Tyler Krompiatek. Yeah, you moved it. I did move it a little bit, I'm sorry. And if anyone's interested, I can, of course, let you scan the QR code after the session. Anyway, so open source and 3D printing. Actually, 3D printing started off as an open source, well, at least commercial 3D printing started off as a as a open source project. There's actually 2 different open source projects currently, the RepRap project and the Boron project. And I've also listed a couple of 3D printing manufacturers. This is for at-home 3D printing. In general, all Prusa printers are based on open source software and hardware. Ultimaker started off as an open source project. I think they were based on the RepRap project actually, but I'm not entirely sure about newer Ultimaker printers, and some of the Creality Ender 3s are also based on open source hardware, and so on. In general, I would say if you are really interested and really looking for an open source 3D printer, do your own research. I've given you like starters here, but that's really about it. So I'm going to start talking about the CAD program that we use as well. We started getting into FreeCAD, which my colleague, Dr. Mark Gallimore, will talk a bit more about in a moment here. So in general, we use a CAD software called Tinkercad. It's freeware. It's not open source, unfortunately, but it's good freeware, in my opinion. So I'm just going to open the project really quick. The account for Tinkercad is free, even though it is it's made by Autodesk. So you can actually start doing this yourself. It's targeted towards middle schoolers mostly. And off to the right here, you have a bunch of base objects. You can also switch between and go to other types of objects, including design starters, characters and creatures, and so on. But for right now, we'll just stay in the basic shapes. We'll start off with a cube because that's typically what most 3D designing models do. And all you do is you grab it in the little sidebar here and you drag it onto your work plane. And here you get a bunch of things that you can do. You can change the radius of it so that it's less pointy and more rounded. I'm using the middle mouse wheel right here to scroll in and also to move around. Steps does something, I forgot what it does, because I've been using the other one, FreeCAD, a lot more. You can change the length, the width, the height, etc. The cool thing about Tinkercad, though, is you don't have to get super complicated with it. What I can do, actually, is if I want to make a hole in this thing, say I want to put like a tube through this rectangle for whatever reason, I can actually go in and grab this cylinder right here. Oh, well, that's new. You can tell that I haven't used it in a while. I apologize.
They added that. It must have been this last week.
Gotcha. Okay. But I can resize this cylinder really quick. Move it around. Make sure it's going through. And just to center the cylinder in the cube, go here, grab both of them, and just align them really quick. And now what I can do with the cylinders, I can actually turn it into a hole and group this cube and the cylinder. And now I've got a hole in my cube. So this is a very basic project kind of thing that I'm just starting off here. But you can kind of see the potential of it, right? If I actually go back to my dashboard here, I have a few other projects that I've used Tinkercad with, or Tinkercad for, rather. I've got a bunch of nameplates that we've used for various people here at the college.
The doorstop.
Yep, the doorstop, which is printing over there right now, and a couple of different signs that I've created for various things, as well as a few student projects. This is my favorite sign, for semi-obvious reasons, if it will load. Just going to tinker this really quick. And actually, I don't know if we actually brought it, but yeah, if you do decide to go over and take a look at the printer, please don't touch it. You might hurt yourself. So one of the cool things about Tinkercad is that it can also take in what's called an SVG file, which is basically just a 2D flat file, and you can actually turn it into a 3D object. I think that's one of the cool things about Tinkercad. That I'm not sure about what other CAD software can do. I'm sure they can do something similar, but yeah. So back to the presentation. My colleague will talk about FreeCAD in just a moment, like I said, as well as resin 3D printing. Yeah. Another thing that you can use is Blender. We use Tinkercad for more technical work, and FreeCAD for more technical work, but for Blender, that's great for like sculpting and stuff. I'm sure there's a add-on with Blender that you can use to turn into a CAD program as well, but I'd rather not get into that. So, yeah. So to export a STL from Tinkercad, which I will just use this one, you can just click on Export right here, and you can choose OBJ, STL, or I'm not sure what that file is. Typically, you want an STL file. This has the best information for a slicer. A slicer is used by a 3D printer, or rather by the object, to translate it for a 3D printer so that it can print. You can't just take a STL file, load it up onto a USB or micro USB, and toss it into your printer and expect it to print. You need the slicer for that. We are using Prusa Minis here at the college, so we use the Prusa Slicer, which gives the best information for our Prusa Minis. I'm just going to show this on the desktop really quick.
This is the brand name of the printer?
Yes.
Joseph Prusa in the Czech Republic produces them.
In the Prusa Slicer, you can zoom in, zoom out, rotate, there we go. You can also do the same thing in Tinkercad. You just use most of the mouse mostly to do all of that. But to import an object, you can just drag and drop it into this thing right here, the build plate, or you can go to Import, STL file, desktop, click on Open, and this is kind of where the magic happens. Actually, Prusa Slicer is one of my favorite slicers because it does have a lot of automatic things that you can do in it. So for example, you see this triangle with the exclamation point in it, and it's basically saying, hey, this thing is broken. And that's one of the things you always have to worry about when you are designing models for 3D printing, that something on it is not going to work correctly when you just send it through the slicer. So if I just click on that, it will try to fix it for me. And there we go, it fixed it. I don't know what was wrong with it, if I'm being completely honest. I thought it was a good file, but obviously it is not. I can also resize this. There's a bunch of options over here to move and resize it as needed. But I like using the scale factors right here. So I'll just say 75. And there we go. So, other things that you can do with a slicer. In some cases, when you are modeling, or creating models rather, you need to use supports. So that overhangs, I think, over 50 degrees, maybe a little bit less. Don't just print in midair when they start printing and create spaghetti is what it's called. Actually, on the 3D printing Reddit, you'll see lots of spaghetti and people making jokes about putting it on plates and eating it and stuff. I think someone made recently meatballs for their spaghetti too, so that was interesting. But anyway, I typically just use the auto supports because I figure the slicer is going to know what it needs to do for the printer. But you can make your own supports. This particular object does not actually need supports because it's in that angle there, that range of degrees that doesn't need support. So I'm actually going to turn that off. Infill, that's basically, so on the outside is several solid layers, which is called the outer wall. Infill is the stuff inside of that, which I'll show you in just a second, that gives it the extra strength. Otherwise, you can print it hollow if you are looking to do that, which can be great because then you can fill it with resin or some other thing that cures and makes it more solid if you would like to do that. So I'll just click on Slice Now in the lower right here. I should mention that most slicers have all this, all these things that I'm showing you as well. Like I said, I just like using Prusa slicer because it's got more of those things, and it's also built for our Prusa printer. So, looking at this, you can see all sorts of information in the upper left right here, including about how much time it's going to take to do each part of the model. And this is going to take a total of 4 hours and 14 minutes. I usually add at least an extra half an hour, just because it's not always accurate. So, but one of the cool things that I like about the Prusa slicer here, and like I said, most other 3D slicers have this as well. On the right here, I can actually go through and take a look at this layer by layer, which is really neat. I'm going to find a layer that actually has infill though. At the bottom. And there we go. So this is infill, these red lines right here. I don't know if you can see it super well on the projector, but, and this will provide support for the inside of the model so that when you are pressing against it or putting pressure on some of the walls, it's not going to just immediately fold in on itself.
And you can see an example of a partially printed model up here that has that in it.
So you said earlier that you could fill it with something like epoxy somewhere. How would that work?
So you would actually pause the printer mid-print and then start filling it. And then you'd let the printer go, continue on, and then as it gets up another 7 layers, you would pause it, do it all over again, and keep on going from there. It's kind of backwards, I admit, but...
There's a couple of different techniques. You could also print a hole in it, pour it in afterwards, and plug it.
Right.
Which you have to do for resin printing anyway.
So I can also set the infill to 100%, which you really don't want to do necessarily. Because yep, it'll take a lot longer for one thing, and for another thing, after I think about 2025-ish, the benefit of printing more infill just isn't worth it. After about 25%, you're just not getting as much return on it.
Will it let you set the infill low enough that there'll be structural integrity issues, or does it have a limit?
It can actually, so I can actually set this infill to 0.
Okay.
We slice that really quick.
And that can cause problems.
Yeah.
Not always. It depends on the model.
Does it know that it's going to cause problems, or?
No.
Oh, no, it'll in 3D printing, the printer and the slicer will let you do all sorts of bad ideas. Not stand in your way.
Let you shoot yourself.
Pretty much, yeah, exactly. Alrighty. So I did that a lot faster than I thought I was going to. Does anyone have questions really quick?
So is something like Prusa Slicer available to any sort of 3D printer? Like, since
Yes.
it's like an open source, and so I like a second question to that, is there any sort of 3D printer that cannot use another like software for slicing?
So the slicer, as far as like what printers can and cannot be used, are based. Slicers have printer profiles, is what they're called. That has all the information of the printer. In some cases, you have to customize it yourself, and in other cases, it's just there for you that you can just grab. Other slicers that are used in general is Ultimate Cura, and most printers also have their own slicer, which is based on open source software like Slicer or Ultimate Cura, like I just mentioned.
And it seems like it seems like Prusa Slicer has from my own research, it has a feature that allows you to like cut up a file like without having done it yourself.
Yep.
If you have something like too big to print on the printer that's available to you, you can like cut up using the slicer.
Yeah, I haven't used that myself because I usually keep it within the size of the minis because we don't usually need to print anything bigger than that. But yeah, it can do that.
Yeah, I have a personal project that it's bigger than the printer that's available to me.
Gotcha. One of the cool things about the Prusa slicer that I'll just mention really quick is that they are going to have something called tree supports, which is going to make it a lot easier to 3D print things because you're not print, and it's going to make 3D printing a lot faster as well because you're just printing the stuff that you need rather than everything. So, do you have a question?
No.
Okay, cool. All right. Anyone else? No? All right. I'll pass it off to you then, Mark.
I'm going to start by saying the credit here goes completely to Tyler. I run an office called the Center for Online Learning and Innovation, which is a fancy way of saying we help people use digital stuff to do a better job, teaching, learning at the college, professional work. And Tyler joined my office in 2020 and really brought 3D printing with him. I had notions that I wanted to 3D print because of some personal hobby stuff I do, which is going to be sort of made manifest here in a minute. But he made it seem a lot more practical and doable, and ultimately is the reason my office is involved. And just as a sort of an overview, we've had a lot of different student projects that we've printed for classes, for the local tabletop gaming society, who obviously is very heavily invested right now in 3D printing the broader community. And let's see here. Text. So that was it. That was a hardware problem. And we've kind of done a thing which you probably shouldn't do with a budget, which is build it and they will come. But once we had these hammers, nails appeared everywhere. Like, we had all kinds of uses for 3D printing. Like, we want doorstops in a hurry. A poetry class wants to write about an object in their mind's eye before it's a thing, and then return and write about it after it's a thing, a three-dimensional object, and explore differences in thinking about that object's different states. And we could very easily do this with additive manufacturing, 3D printing. So it's been a very successful program. I think we've certainly got our money's worth. These printers, like the one that's printing on the end here, these are hundreds, not thousands of dollars. Prusa's a little more on the expensive end these days compared to Anycubic, Elegoo, Creality. There's a bunch of different brands of printer, and you can go to Reddit communities and see all kinds. There's whole communities built around these different brands and these different products. But that's really, when it comes to FDM, that's your major cost, is the printer itself. The reels, they obviously cost money. My experience is the plastic goes a very, very long way because there's just not a lot of waste. You buy a product, and let's face it, half of it you're throwing out. It's called packaging, right? So, the doorstop for that door is going to be a couple of pennies worth of plastic. And that opens up all sorts of possibilities. Now I'm gonna do two things. I'm gonna talk about resin, and then I'm gonna talk about where we've gone recently with CAD. And we've gone into a product called FreeCAD, which is a truly open source product. Resin. I'm going to start with resin printing. Resin printing, the physical aspects of it are not as simple as FDM. FDM is plastic that gets extruded through a hot end nozzle and sort of gets written in layers. You go over and you could, within a few seconds, you're going to understand what you're looking at. Okay, so it's writing in 3 dimensions with hot plastic. The plastic cools, I have an object. Resin works a little differently, and there's more complications involved. So that reasonable people might say, sure, I will have an FDM printer, a filament printer like that in my home, and I'll run it, no problem. I may draw the line before buying a resin printer, given that I have to buy additional chemicals and handle additional chemical processes. Now, I do this in my home. This is my personal printer. It's a relatively inexpensive Elegoo Mars 2. That's trivial. It runs the same as any Cubics models. We have downstairs in a lab a much more expensive, still hundreds, not over $1,000, bigger, better, any cubic model. You can buy dedicated support equipment like a box that shines ultraviolet light and rotates the printed artifact to carefully bathe it in UV light. Or you can do what I did, which is buy a very inexpensive box for UV activated nail polish. And that's what I bake my prints in. The price was right. So I may upgrade in the future. Haven't gotten around to it. And the figurines you see over there, the sort of tabletop gaming figurines, there's a pair of little badgers in medieval garb, were printed using this printer, not the nicer one we have downstairs. So it shows what is possible. Oh, I have to plug in my mouse for it to work. Another hardware problem. I, too, have used Tinkercad. When I go on to talk about FreeCAD, I learned parametric drawing with Tinkercad. After I'm done talking, I'm going to use FreeCAD going forward, at least for a while. I may transition to Blender in the future. But I recommend Tinkercad to get started, and it's what we teach students to use, because it is so simple to use, as Tyler demonstrated. This is FreeCAD. It allows more sophisticated parts. This is actually a multi-part arrangement. It's more than one part that fits together in a sliding fashion. I use off-the-shelf metric hardware to create a pin that goes through here, so these two parts slide open, and it's a fixture for painting things. But I wanted to discuss how a resin printer worked so you get a sense of what's going on in this technology. So on this printer, there is a build plate suspended above a vat. Liquid resin is poured into that vat to start with. The digital art is given to the printer, and to start printing, the printer lowers the build plate. You can see you can barely see there's a screw elevation actuator behind the build plate. Lowers it into the vat. The bottom of the vat is a clear plastic, and it's called FEP. So the 3D printers refer to the FEP. Underneath that clear plastic, which is tightly sealed so the resin doesn't leak, hopefully it's tightly sealed. Underneath that, built into the box that's the base of the printer, is an LCD screen. And the earliest of these printers used basically old cell phone screens, new old stock, that had been manufactured for earlier cell phones, and the tooling was now used to make these LCD screens for 3D printers. 3D printing has moved beyond that to dedicated LCD screens that are monochromatic. They just illuminate using ultraviolet light. And so the process is the build plate goes down. A layer is a silhouette. It starts as a silhouette of UV light that is flashed up through a very, very thin quantity of the liquid resin that's between the FET and the build plate, and that silhouette is, within a second or two, flashed into hard resin, because the resin is photopolymer activated. When exposed to UV light, it hardens. Goes from a collection of monomers and other supporting chemicals to a polymer. Next layer, the build plate comes up, the UV light flashes, second layer. Third layer might be a totally different silhouette. And so on, and so on, over a period of minutes or hours, depending on how tall your print is. So FDM printers, the time it takes to print is based on really all three dimensions, and a few other things that you can set in terms of printer settings. The principal determinant of a SLA resin print, the time it's going to take to print, is usually its height, because it flashes the whole layer, 2 dimensions of the layer, all at once. Once the print is done, it lifts away from the vat, and you have the next problem to solve. There is liquid resin still coating your solid print. So you need to remove this print from your build plate, and then you need to remove that liquid resin from the print for 2 big reasons. One, because you're going to do a follow-up UV bath to completely harden that part so that it's ready to use. And this stuff is toxic. This resin is toxic. If, depending on your own chemistry, if it gets on your hands, it may be harmless for a few minutes, a few hours. It may cause serious chemical burns after a few minutes, after a few hours. Once the parts are cleaned, bathe them in UV to complete the hardening process, the polymerization process. A few minutes does the job. If you are like me and you have a kind of a jerry-rigged home setup, you may have to turn the parts over just like you were grilling hot dogs to make sure that the UV gets where you want it to be. This also illustrates something else. It's not a great photo because they're kind of small up here, but just as Tyler mentioned, supports with FDM, with resin printing, depending on the orientation of the part and the size and shape of the part and its details, you need to, in the slicer, attach supports. And they get printed along with the thing you want at the end of it. And you clip them away, or to watch YouTubers, you rip them away, which may leave dimples in your part that you may or may not care about.
So this is like sprues when you're doing metal casting?
It is exactly like sprues in metal casting and traditional plastic models. Now, it's a different manufacturing process, but the term sprue is that parts runner you got when you had an AMT car model and you ripped the parts off as a kid and stuck them together with glue. It's a lot like sprue. Yeah. I am a plastic modeler, full disclosure. That's how I got into this. That's the path that took me here, although I didn't really take the plunge until Tyler made it look easy. I'm smugly proud of the fact that I used a 21st century machine tool to make a miniature 1940s machine tool, a drill press. I went to Popular Mechanics magazine on Google Books and found ads for drill presses around the World War II era, and I drew the parts up in Tinkercad. Okay, that's a piece of brass rod. There was no point in having the 3D printer print something that's easy to get. And here's the parts. A jack stand and jacks for a car model, windows and doors for structures. That's a traditional plastic model I put together. I bought that in a hobby shop. And so is the Canadian soldier here. No, I don't wear this on a regular basis at home. The picture is for dramatic purposes. But my emphasis is, play it safe. Either decide this is not for you because not only are you handling this resin, you do wear nitrile gloves when working with a printer. I wear eye protection. And I do wear a white lab coat just so I could see if something splashed, and it's not on my clothing, it's not on me. I just quickly look at the lab coat before I take it off. To clean this resin off, there are water washable resins, but they're environmentally controversial, and they work better if, as a cleaning solution, you use alcohol, isopropyl. You can get full-strength isopropyl alcohol on Amazon, from medical suppliers, that sort of thing. That works best. There's a million different ideas people have about how to clean resin off. That's usually the starting chemical people talk about. So this is what you have to have in your home. I do it. Now, I have a dedicated workspace. I don't do this on the kitchen table and then put everything in the closet when I'm done. But tabletop war gamers do this. Other people, jewelry makers, do this. It is realistic to do this at home, so to speak. But it is something to consider investigating before you say, oh, resin's for me. Why would you use resin? Because the quality of the prints in terms of the fineness of detail and smoothness of surfaces relatively is better with resin. If you look at the little miniature that you may have gotten out of the box that went around, it looks pretty good. Compare it to the fantasy soldiers, the little badgers over there, if you get a chance, and you're going to see the difference. Resin, this is why tabletop war gamers traditionally have gone to resin. Miniature makers, jewelry makers have traditionally gone to resin. But for a lot of what you're doing with 3D printing, you may not need that quality. If you buy a 3D printer, so I bought an FDM printer. I printed, my wife takes care of house plants, is getting into gardening. I printed her a whole bunch of pots and other tools and implements for supporting house plants. I printed my daughter toy animals that have been weirdly hard to get in plastic, in scale with other toys that she has from Fisher-Price. So you may say, well, for my needs, I just don't need the additional complications of resin. And that's great. That's absolutely right. But just so that you walk away today going, okay, I get this. There's two basic kinds of consumer 3D printing. Here's what they involve. And as you can see, with this printer, we were able to bring this into the classroom, hitch the plastic into it, start it up, and we don't need all the post-processing stuff. If you are interested in seeing a resin printer and some of the related equipment and chemicals involved, let us know afterwards. And sometime today, we can set up a time. We can go down to our lab downstairs and show one to you, just so you have an idea of what that looks like, if you're at all interested. The second thing I want to talk about is FreeCAD, for several reasons. So, Tinkercad, I love Tinkercad. I really give Autodesk, the company, a lot of credit for making a robust, easy-to-use tool set free. And it's used across education for all the right reasons. However, you will eventually run into limitations if you really get into designing your own 3D parts or other things. And there you're going to need to adopt a more sophisticated tool set. No surprise. Tyler mentioned Blender, which is excellent for more sculpting kinds of work, and there are ways in which it can be used in a CAD type of way. I will probably try to learn Blender in the next 2 years. I went for FreeCAD because I come from a family of engineers, and so CAD is I knew what CAD was, and I knew some things about it before ever I downloaded FreeCAD. And it comes recommended as a next step past Tinkercad by a lot of 3D printers. However, I'm going to finish. I don't know if I'll have time to show it, but I will say it has a bug. Its defenders are adamant that that's not a bug. That's an unfortunate feature. It's a bug. For normals, for people, hobbyists, weekend warriors. And that does, to some degree, can limit its usefulness. It has not scared me away because I've worked with it and I've worked around it. But anyway, let me get started. I'm not going to show you how to use it so that you'll walk away and be able to use it. It's too complicated to do in 10 minutes. But I will show you the workflow that will make the tutorial YouTube videos make sense faster. Which is really, with FreeCAD, that's usually the thing about, well, there's this really steep learning curve, a really difficult learning curve. I'm hoping to make that easier by showing you the basic workflow to get to a part design in this software. So, FreeCAD, it looks like a drawing software. Okay. It has these workbenches, which are collections of tools you use to do all kinds of different work. And there are whole workbenches of tools that are not useful necessarily for 3D printers, or they don't mention them anyway. They may be more useful for architects, designing houses or something, real-size houses. Typically, YouTube videos teaching beginner FreeCAD for the use in 3D printing say, go to the part design workbench. That's your headquarters for 3D printing. So I am going to create a new drawing. And obviously there's a new button, just like Microsoft Word. And then I'm going to make sure I happen beyond the part design workbench. So I'll stay at the part design workbench. Then the process is this. You create a 3D object from an initial 2D drawing. And then you subsequently make additional features or cut pockets, depressions, holes, things like that in your initial 3D part with more 2D drawings. And you'll see what I mean. So I click this button here that takes me to the sketcher to do a 2D drawing. And FreeCAD says, which plane of the global coordinate system do you want this part to be oriented with or against? And you can see what's going on here. XY plane, horizontal, XZ, YZ, two vertical planes, 90 degrees from one another and 90 degrees from the horizontal. And in FreeCAD, these are also referred to as the origins. So I'll click the XY plane. And then here, my tool sets are all missing because the screen is... cheat by...
Click on the double arrows next to far right side.
Yeah. Okay. This'll work. So I'm actually going to start by creating a circle. And let's make it around 60, but we don't need to be accurate to start with. And I'll create another circle. And these are just mouse clicks, what you'd expect. If the first thing you walk away with about FreeCAD today is 2D drawings into 3D drawings using that part design workbench, using the sketcher workbench, you're drawing objects, and then you are constraining them. You're using what are called constraints to make sure those objects are precisely what you want, literally and figuratively precisely what you want. So I click on one of these circles. I find where the, constraints. There's a constraint tool here to just constrain the size of the circle. So I'm going to say 80 millimeters. Actually, let's take that one down to 40 millimeters. Okay. And I'll zoom in a little bit. Click on the second circle. And I'm used to seeing all my toolbars. This is why this is a bit more challenging. 80. Okay. And then I will add 2 lines. Oh, it's right in front of me. And then I will click one of the points, click the arc, and I will use what's called constraint tangent to connect them. And so, in general, you get a good idea of what's going on here. You're going to use a series of the different drawing tools, which are not by themselves dissimilar to what you might find in, Google Drawings, something like that. More complicated are these constraints. So now I've got only one quote-unquote degree of freedom. And that's, I can move the length to establish the length of this part. And this is showing me how the constraints have attached diameters, and I can move those around. I'm then going to need to get rid of, so that it can extrude, it can make a 2D drawing into a 3D part, I need to get rid of these interior lines here that would confuse FreeCAD because they're connected to this exterior wire, as FreeCAD calls it, the outer perimeter of the part. So I'm going to find where they hid them on me. Right here. Trim edge, click that. Trim this part, trim that part. Okay. I'll hit close on the sketcher tools. And I have my wire 2-dimensional drawing. Now I will make sure that's highlighted and click the pad icon, and it's a 3D drawing. Yay. And I can set that to, let's set it to 30 millimeters high. That's fine. That'll work well. Now, because it's a real CAD program, I can add what I need. I need a hole here. Let's say it's for a crankshaft. I need a hole here. Let's say it's for a fastener of some kind. I can look at this pad, as it's called, which was the act of turning it into a 3-dimensional drawing. I'm actually going to rename that. Instead of just the generic pad, I'm going to call it height. I recommend, speaking as a newbie, get into naming things in this tree. Otherwise, as you create more and more things, and you've got a bunch of things called sketch, sketch 01, sketch 02, sketch 03, pad 01, pad 02, you're not going to know what you're looking at anymore. Rename it however you want to do it. But inside of that, I can still find the sketch. So I click on that, I'm back here, and I can draw a no, I want circle. There we go. and I'm going to draw a tiny circle here. Then I'm going to use that a little differently. Now I hit close, and automatically FreeCAD says, okay, he wants the reverse of the elevation. He wants those to be holes, those to be voids. Great. This one's a little special, though. I'm going to click on the edge of that circle, and I'm going to come up to, I'm going to go to this tool set, and I can create just a depression, but I want to use the hole tool specifically. This is for standard hardware fasteners, maybe among other things. But under Profile, I can find metric hardware. And then as anyone who's ever built a PC, let's choose an M6 screw. It's going to size the hole appropriately for that size screw. I can then do some other things. If I wanted to, a machine screw that I needed a countersink, I can automatically install that. Or counter bore, and let's say 12 millimeters wide and a millimeter depth of 1. Okay. So I've given you a simple example. Now, I could immediately draw another depression on this plate at a different depth. Here, let me hit OK on that. By clicking on this surface and then using the sketcher to do a drawing. It probably would be fine. However, if I did it that way and I later modified this solid that I've already created, it might throw an error. It might move that depression to some other face. This is what's called a topographical naming error, and FreeCAD suffers from it pretty badly and pretty quickly. Other CAD drawing softwares can suffer from it, but not nearly as quickly or badly. This is open source software. The developer team does what they can with the resources they have, probably time being a big one. So this is something that maybe Autodesk would work out pretty quickly if it appeared in Fusion 360 or something like that, but right, there are workarounds to that problem. And I'm already comfortable with those workarounds, so I will continue using FreeCAD. But it does sort of illustrate this is the dilemma with open source and the fact that there is this sort of extra step. And the community comes divided. Some folks say, oh, this is a deal breaker, I'm not going to use FreeCAD. Others say, well, but the workaround is actually not a workaround, it's an excellent engineering practice, which is to create a datum plane and then attach that datum plane. You can see the datum plane. I can attach it as a proxy to this surface and then draw on the datum plane. And then even if this changes, the datum plane actually has that additional sketch. It's complicated. But you'd figure it out if you wanted to. And, you know, you get engineers on the web who are like, well, that's actually the proper way to do CAD anyway. So you want to, you know, eat your vegetables and use datum planes anyway. And I don't know, I come from a family of engineers, so I'm sort of, yeah, right on, you know. Your mileage may vary. I will also admit that, look, if I know these dimensions are good, I might just add a sketch directly on that surface, get the part done, send it to the printer, pow, I'm done. No problem. Because I'm not going to make extensive modifications to what I have that could cause that error to throw. And then in FreeCAD, I've just given you this basic, all right, I didn't do my, okay, let's just cancel it. I've given you the basic get started way to think about it. 2D drawings, extrude them to 3D, either parts or wholes, using the part design workbench and the sketcher workbench. Now go watch the YouTube videos. There's great YouTube tutorials out there, and it will make sense, hopefully, in 10% of the time it did for me when I had to sort of figure that out just with the internet. Thank you for coming today. Take a look at the 3D printed examples and the printer over there cranking out a doorstop.
Also, if you didn't get a griffin, we'll have that over there as well.
And questions, comments, it's lunchtime, so we'll be here for as long as anybody wants to talk to us.
What time were you thinking about doing the resin to? Because that's very enjoyable.
What's best for you? I mean, since you asked, we can do it like in a few minutes from now. If you'd rather eat lunch and there's a
Maybe
session.
late lunch? Maybe late in the lunch hour?
Sure.
12:50 or 12:45 or something?
Yeah, what do we say, 12:40?
How long do you think it'll take?
Not much. I mean, I'll show it to you. I'll take the top off it, and you can see how it works or something. Right now, we don't have plans. If somebody really wanted me to fire it up, we could, but we don't really have plans to do that just because of the, you know, there's not a lot to see when we start it up. I mean, you know.
It all happens under resin.
Yeah, it's all happening. That's a good point.
So meet here at 12:40?
Sure. Yeah, that'll work.
Earlier, you had been talking about if like somebody doesn't want to go through the hassle of like all the chemicals and like excess it takes for resin printing. If you were looking into buying food for your own home, what precautions or steps you might want to take to ensure that it doesn't malfunction or something like that? Or if you need to replace a nozzle and you just don't have the know-how to do that yourself, what is like are there places to take your 3D printer if something goes wrong with it, or is there enough like internet like sources and things to help you with most issues that I might have? I just know that sometimes it's like they malfunction or whatever. Like, I don't know how to fix it.
Maybe the maker's space.
There are local communities of people who can help you, certainly. I would also say that I'm just like, for the first time this week, I replaced the hot end nozzle on my Anycubic, I forget what it's called, and you know, if you just grit your teeth and try, it's doable. It is.
And so when you realized that you had to replace that hot nozzle, what you're saying, did something have to go like catastrophically wrong for you to then have to change it? Or was it
funnily, no. So it comes with a brass nozzle. The concern with any brass manufacturer is the potential that they use lead when they manufacture brass. So a relative of mine asked, "Can you print cookie cutters?" Well, sure. So I bought food-safe plastic, and then I bought a stainless steel nozzle to ensure that there's no lead contamination. So I didn't even have a problem. It's the eagerness to, you know, again, like once you have one of these things, you want to print some more. And anybody, I mean, you know, if somebody says to me, "Hey, can you know, print an aircraft carrier?" I'll get right on it. Like, you know, you're always, you know, you want to print. I was scared of replacing the FEP on my resin printer until I just buckled down and did it. And I've done it a couple of times now. What other things have I done that I was scared to do? My Elegoo Mars had a problem where the connection between the LCD and the motherboard, just the connector keeps coming loose. So I gritted my teeth, got out my iFixit kit, opened the front. Sure enough, there it was loose. I was like, oh, hey. So I pushed it back into place and then prints. So I would say, you know, sorry?
Little dab of hot glue, it won't fool again.
So actually,
You know, that's it. Like, I mean, you just you know, have a little courage, and you can do a lot of that stuff on your own. But there's also, you know, if you pretty quickly identify a local 3D printing community, which may be an actual like 3D printing community, it also could be, I don't know, you're on a Reddit thread and a couple of people live in the Buffalo area or something like that, you know, and yeah, you probably can get help if you needed it or something to that effect. But